Welcome to this comprehensive guide on unleashing ECS, data-oriented design in Unity, tailored specifically for beginners. The Entity Component System, or ECS, represents a fundamental shift in game development within Unity, prioritizing performance and efficiency above all else. It's a core component of Unity's data-oriented technology stack, known as DOTS, designed to help developers build more intricate and detailed games. These games can then run seamlessly across a broader spectrum of hardware, offering a consistent experience to a wider audience. At its heart, ECS is built upon three core concepts: entities, components, and systems. Entities are essentially identifiers, acting as empty containers that represent objects within your game world. You attach data and logic to these entities, defining their characteristics and behaviors. Components are where the data associated with these entities is stored. Unlike traditional object-oriented programming, ECS components are organized by the data itself, which significantly improves memory access patterns. These components are typically implemented using C-sharp structs, ensuring efficient data handling. Systems contain the logic that processes this component data, operating on entities based on the components they possess. Systems define how data is transformed and how the gameplay mechanics unfold. ECS is fundamentally rooted in data-oriented design, or DoD, an approach that focuses on how data is structured and accessed in memory. DoD stands in contrast to object-oriented programming, which primarily focuses on objects and their interactions. A key principle of DoD is optimizing memory access by arranging data in contiguous blocks. This contiguous arrangement significantly reduces cache misses, leading to substantial performance improvements. DoD often employs structures of arrays, or SOA, to store data. This means each type of data is stored in its own separate array, rather than bundling all data for an object together. Another crucial aspect is the use of blittable data, which can be copied directly into jobs without additional processing. This typically means avoiding managed types like classes or strings within your components. To begin your journey with ECS, you'll need Unity version 2.02, 2.3.0, or later. It's also highly recommended to use either the Universal Render Pipeline or High Definition Render Pipeline for optimal results. The first step is to install the entities package directly from Unity's Package Manager. Subscenes are then used to create and manage your entities directly within the Unity editor. Creating components in ECS is straightforward. You'll start by creating a standard C-sharp script in your Unity project. The crucial change is to replace the mono-behavior inheritance with the iComponent data interface. Additionally, define your component as a struct instead of a class for data-oriented efficiency. Next, let's look at creating systems. Similar to components, you'll begin by creating a new C-sharp script. You'll need to incorporate specific using statements, such as Unity, entities, Unity, mathematics, and Unity, transforms. Finally, convert your class into a partial struct to properly define your system. Adhering to best practices and optimization techniques is crucial for maximizing ECS performance. One key practice is to maximize chunk occupancy, aiming for as close to 128 entities per chunk as possible. This strategy significantly reduces the number of chunks that the job system needs to process, boosting efficiency. For data access, always iterate through component values directly rather than relying on indices. Accessing multiple components in tandem can also lead to improved performance. Leverage the C-sharp job system to run your code in parallel across multiple threads, utilizing modern CPU architectures. Additionally, the burst compiler can transform C-sharp code into highly optimized native code, further enhancing executions. However, avoid premature optimization. Don't use the burst compiler by default. Be cautious with the job system as well, as it can sometimes make code harder to read and maintain. Regarding code structure, flatten your game logic into top-level systems instead of deeply nested class hierarchies. This approach makes your code more discoverable and significantly easier to maintain. Ensure that components are written to by only one owning system to prevent conflicting systems from overriding each other's results. Finally, always use performance tests to compare different approaches and identify the fastest methods. Pay close attention to code generation and the complexity of the API when evaluating performance. By understanding and applying these principles, you can harness the full power of Unity's ECS and data-oriented design. Thank you for joining us on this journey into high-performance game development with Unity ECS.